Let's talk about the intersection of the lines. So say we have the intersection of two lines. So in 2D two-dimension vectors, we have known that the intersection can be so the two lines can intersect, and this is the situation where two lines actually touch it and there's a one common point. So that is situation where the two lines intersect. So this is one point, one common point. Now there are other situations when the two lines are parallel. So this is the situation when the two lines do not touch at all, and the two lines so this two lines do not touch. And now as we move into 3 dimension, there are another situation where we call it the skew line. So we have this skew lines. Now the skewed line is where the two lines do not have any common point, just like the parallel, but it is a little bit different. So in the parallel, the two line is in the same plane, so which mean that so when they are in the same plane, if they don't intersect, they are parallel. But the skewed line is usually when they are on different plane. So imagine thing in 3 dimension, we might have a plane right here. This is a plane, and you might have another one down below it. So we have another one down below it, and the skewed line is the situation where the line on parallel. So we may have one line here, another line is down there in another plane. So you can imagine that because these two plane don't intersect, these two lines cannot touch. So simply imagine the thing in 3D is how, so this is the distance between the two lines. So this line is in the above plane, and this line in the below plane. So imagine there are two two pieces of paper hanging in the, say, the air, and one is in another piece of paper, and one is in the other piece of paper, and those two cannot intersect if the two pieces of paper touch it. So the skewed line is where there is no intersection as the parallel, but the lines are in different plane, so that it doesn't touch, sort of thing. And so that's just the basic idea. And the point is when they give you two lines and you have to figure out what kind of lines they are. So I'll show you how you figure out what type of line you can find out from the question. Let's say now we have an equation here. This is an equation of say line 3, 5, 4 plus constant time 6, 8, 10. And this is another line where we have the point, I say 1, 3, 5, and plus a constant of 3, 4, and 5. Now simply you can realize that because this part show the direction of the vector of the line. Let's say it start at a specific point and it follow the direction. Now this can actually be reduced to 2 times the constant 3, 4, 5, which is the same as this one. And imagine this is another point which had it also follow the direction the same as this one, and in this case it start at 2 different points but it follow the same direction. So it is good to know that when these the direction here are the same, these two lines are called parallel. So remember that when these two, so the one after the constant actually show the direction. So if these two can be reduced to be the same, these two lines are parallel. So remember that in this case, these two lines are parallel. Now let's just say we have these two lines. So here we know that these two are not parallel. So this is 2 minus 3 and 4, this is minus 1, 2 and 1. These two cannot be reduced and they are not equal. So these two lines definitely not parallel. So they can either be skew or they can either be intersect. Now if they intersect, we know that there's one point where these two meet. There's one point where these two meet. We can just rewrite this equation. So 1 plus 2 constant, this is 2 plus, minus 3 and lambda. Now this is 1 plus 4 lambda. And this is equal to 4 minus mu, minus 2 plus 2 mu, and here is 8 plus mu. Now these two are intersect, so it shows that we must have 1 plus 2 lambda is equal to 4 minus mu. 1 plus 2 lambda is equal to 4 minus mu. And 2 minus 3 lambda is equal to minus 2 plus 2 mu. And from these are the two equations. So we can find mu to be equal to minus 1 and lambda to be equal to 2. And from these values, we can try them here. So here we have minus 1 plus 4 lambda. So this is 7 on this side, and 8 plus mu, that's 7 on this side. So these two are the same. And also from these we solve for mu and lambda. So this is equal to this is equal to this, and this is equal to this. Thus this is one point and these two lines actually intersect. Now when does the two lines are skew? Similarly, if here this is not 8 but this is say 9, so these two are not equal. So in the case where the two lines, when we try to find a point of intersection and we cannot find it, that means there's no point of intersection. And if the two lines are not parallel, we know that they are not skew. So that is how you figure out if two vectors are skew or are parallel or are they intersect.